So we're back looking at tables of linear functions, and to go back to the slide that we looked at in the last video, key features of linear functions in tables is that each row and each column must be linear, such that all the rows have the same slope and all the columns have the same slope. So if we go and we're given some table, and let's suppose that we're trying to find some unknown entry, what we can do is we can think, well, we know that there we had a change of from 0.5 to 1.5, we had a change of 1. So as we changed our y values, so the change in z as we changed our y value equaled 1, because these are my y values, these are my x values. So similarly, as I change my y value again, and that was a change of 1 for a y value change of 0.5. So given that we have the same change in y from 1.5 to 2, here I would expect the same change in my z of 1. So from negative 0.5, if we're increasing by 1, we get to 0.5. So this value here should be 0.5. And if we make it that way, looking at the rows, in both row we have an increase of 1, and in both columns you'd have a decrease of 1. So both the rows and the columns are acting linearly. And the last idea here, let's suppose that we have a contour diagram. We want to get the equation of the linear function. So first of all, right away, if you're looking at a contour diagram, a feature of a contour diagram that always must be true for the function to be linear is that the contour diagram is linear and evenly spaced. And remember, contour diagram is giving us 3 pieces of information. We've got our my x-axis here, my y-axis, and each of these contour diagrams are telling me my z value. So here all the z values are negative 10, negative 8, negative 6, negative 4. So the idea is let's go to a point, an easy point, a decipherable point. Let's go right here to the origin, and that happens to be on the contour line when z equals 0. So we know that we contain the point 0, comma 0, comma 0. And if we think about what's the change in z as we change x, so let's hold y fixed, and let's start at this point, and let's move over until we hit another contour line. So we had to move over 2 in the x direction. And when we did that, we went from a contour line of 0 to a contour line of 2. So the change in z was 2. So that shows that dz dx equals 1. And notice that's going to be the case anywhere. So, if I go choose any point, and if I move my x over 2, I'm going to see a jump in my z value from 4 to 6. So I'm going to see a jump of 2 again. So the slope of 1. Okay, so that's dz dx. What about dz dy? Well, or delta z, delta y. Same idea, but now we're keeping x fixed. So we start at our origin, and we go up, and let's go up until we hit a very easy contour line, so right there. So we had to go up 2 in the y direction, and when we went up 2 in the y direction, we went from, our z value went from 0 to 6. So the change in z with respect to y was 3. So what would be the equation of this line? Well, we'd have z equals my x slope, so 1 times x minus 0, because I'm using this point as my point, plus 3 times y minus 0 plus 0. And again, I don't need all those zeros in there, but I'm just having them for now so that we become comfortable with a point slope form. And so this gives us an equation of this contour diagram. In the next video, we'll be looking at a bunch of problems and have you have an opportunity to stop the videos and check for your own understanding. So please look ahead onto the next video.